Hi, it's Tom here from Foam Data Services, and today we are going to be looking at the Nerf Stryfe. Now, obviously the first step in this guide is going to be to take the shell halves off. I'm not going to show you that. If you can't get into the blaster, you shouldn't be working on it. So we're going to start with a quick overview of what's where, and I will start with, over here we have flywheels, wiring cover, we have the dart sensor, we have the jamb lock, mag lock, the mag retaining clip here, and mag release. We have the trigger, we have the pusher, we have the rev trigger assembly and the trigger locks. Here is the return spring for the pusher, and here is the thermistor. So this is going to serve as a guide on how to rewire the Stryfe for high power batteries and for better performance. This will work with pretty much all the common motor types. The wiring we're going to use is capable of handling massive current compared to stock. So you can use this for 180s and downwards, right up the way to the top end ball bearing neo-magnet 180s. And this is quite happily compatible with up to 3S LiPo. So if you're just using IMR cells in the battery tray, or you're just going to put RM2s in, you're well over spec'd on this one. And you can use a different wire of choice if you like, but we're using a 16 AWG mil-spec silicon insulated wire. There's a number of different manufacturers for this. You can get it however you like, local hobby stores, Maplin, places like that. Right, stuff for the bin. There's the maglock, cause of so many woes in stock Stryfe. Spin, and let's keep that safe. Now you can remove the trigger assembly and the pusher, save them for later. Okay, so we've cleared out the clutter now so that we can better see what we're actually taking out. And this is a good stage to quickly review the standard wiring setup. And you can see here there's a feed from the battery tray and the other feed from the battery tray. This top one is the negative feed from the battery tray, and this bottom one is the positive feed from the battery tray. So if you're using any kind of lithium-ion, it's well worth knowing that those are the two feeds that you need. And the positive feed goes down here into the red rev trigger, then it goes up here, and it goes through the magwell trigger, and then it goes on up into the jamb trigger before passing into the motors. Both of those have to be depressed like that in order for the blaster to fire. And then the negative feed passes through the thermistor, and that just goes direct. So all of the lock gates are effectively, and the gate down here, are all effectively on that positive feed. It's a really simple blaster. The modified wiring loom for this is literally 3 wires. So what we're going to do is we're going to rip this out. We're going to rip this out, but you could leave the switch. I keep this switch in place because you can use it to wire LEDs. You just run a feed through it and out, and then I put 3 LEDs in here, it wired into the top of the magwell, and that just gives you a bit of light if you get a breakdown in the dark, or if you want to put LEDs in a UV, you can also charge glow-in-the-dark darts, which is pretty cool. So I'll be keeping that. Right, now if we examine the motor, okay, here are the 2 rubber retaining strips. These are just here for anti-vibration and just to stop the motors from sliding out. Then we have the inductors here, and I always make my first cut in this area, so start by taking the motor cage off, and then I'll just get these and I'll just clip off that one and that one. So now you can see there's we've got a handy red and black thing going on there where you can see which way to wire your motors later. There's your positive feed and there's your negative back to the battery. So you can see which way to wire your motors if you leave that stub on. Now we can just go back, lift this out of the way. Just cut all the stock wiring out. You're not going to use any of it, you don't need it. It's just, if you must keep wire for using in LEDs and things, then you can, but I skip all of it. It's just cheap junk wire. So you can see this one here is the output to the motors, and that's the one that you're going to use for your LEDs. So it's worth leaving a stub of wire on there to remind you that that's the one. You can desolder these later and make them look neat. So that's out, take that out. Don't need any of that, all of that in the bin. So that's where it belongs, junk, 24 AWG, thin, low spec wire bin. Right, maglock. And again, I leave a little stub of wire at the other end. Trim this off now, look, taking the mag block out, and I'll trim it off down here at the flywheel trigger. Leave a little stub of blue wire. Again, you don't need that. Leave a little stub of white wire because that reminds you which one's which when you come to do the switch. Take that out, it's in the bin. Okay, there are your lock components bin. And then I tend to put this back like that. Stick the cover back in there because it stops dirt getting in from the mag well. If you're an HVZ player or you play a lot outside or you have a nasty habit of picking up filthy darts off the floor, this is useful. And sometimes you get some foam residue blowing back through there too, so anything that keeps it out of the trigger area. Okay, so there is your bare shell for rewiring, and then I'll put the jamb door switch back in its location to remind me to keep it so that I don't throw it away. So we put this back in, you can see it's all bare now, and then you've got negative, positive on the battery. Just as a reminder, if you have trouble remembering, I just put a little negative symbol here, usually with a magic marker, a Sharpie or something similar, and just to remind you which one's which so that you don't wire this end backwards, and then you'll have your reminder here on the motors. You should have your reminder wire again on the motors to work your way through that. So, next stage, take off the rubber covers because we don't want to set fire to them. If you're replacing your motors, go look at someone else's mod guide. I always just use the stock Stryfe ones, they're fine. So the first thing we've got to do is we've got to cut the wiring loom for the motors, and you're going to need to measure your wire from here all the way down here, and it must loop round this way and then come down. So you start with the positive, I always do it, the feed from the switch first, because that's the longest wire. So on Nerf we have a wiring scheme, and we have red wire for positive power from the battery, we have black wire for negative power from the battery, and then we have blue wire for feeds from switches. So in this case there will be a length of red wire from the positive to the switch. There will be a length of black wire from the motor cage. I'm just going to sit that in place. So from the negative on the motor cage, it will run down and through the wire run, and it will go straight to the negative of the battery. That has no interruptions, it's just a single piece of wire. And then there will be a third piece of wire which will run from the flywheel switch up through the blaster, snaking back through the wiring run and to the positive on this terminal. So that is literally 3 wires. Okay, anyone who says this is hard, the skills may take a little time, but the actual logic of it is ridiculously simple. It's not voodoo, it's not some kind of weird electronic stuff where you need to have a PhD in microelectronic design or God knows what it is to do this. It's extremely simple. Soldering is a simple mechanical skill. Practice with some of your crap wire. You've got a good load of spare bits of wire now to practice soldering with. Bag your blaster, spend an hour with your soldering iron, and then you can come to put it back together. So I'm going to cut all of the wiring to length, and I usually start with the longest wire, and if you're like me and you're bad at measuring, keep your wire uncut from this end to here, because otherwise you'll cut it too short. And if you don't want to waste it, you can even leave it on the reel. But I'm going to go and pre-cut mine, and I'll get it all set up, and then we'll go straight into wiring. Okay, so we're ready to actually start soldering up now. So I'll start with the motor cluster, and I'll put this somewhere where you can see it, because it will make life a little bit easier. Now this isn't going to be a fantastic view, I'm kind of having to solder across myself. So, first things first, we're going to start with the positive feed. This isn't a critique on my soldering technique or anything like that, it's not intended to be, it's just intended to be how I wire them. So if you see me doing something stupid, then that's just the way I've learned it, and you'll have to live with it.